evolution of the king crust. So, and during our research, we found that the geochemical data or the age data um, may not be right. I think so. We just correct those data. We have already completed one third of the data, and we just put some results of them. And we downloaded the data from the Archean database, and it contains about in 12,000 Archean samples, igneous samples, and we just collect about 3,600 samples here. This is edge distribution for those samples. You can see that uh, the age is very high at about 3.1, and after um, looking at the original publication of every uh, publication, we found that a lot of range are giving us from the 2.5 to 3.8 billion ago. So a lot of data here. So we just look, just checked every publication carefully and correct them. This is the correct age distribution of those samples. So you can see that the higher age at the 3.1 is disappeared at this new figure, and samples from the 2.7 or 2.8 is increasing, and we just using those correct data to plot, and we compare to previous work, and is published in Nature by the Keller and Sean 2012. This is the Archean samples here, and for these mafic samples. And this is the new pattern of our work. And we found that the gray dot point is to get data, and the circle here is the average value by bootstrap resampling measured in 100 million being. So, and this pattern is, I think, is different from this work for the magnesium, and for the nickel, we also plot the data, and we found that it's different from previous work. And also for the sodium, I think it's different from previous work, and for the potassium, I think it's different. And interesting point that for the lanthanum to urapid, I think the change time is about 2.7 billion ago, just from those data. Maybe after complete more data, and we will find some new pattern. And interesting, we found that the pattern for the Archean samples is I think it's very it's the normal distribution, and I think because a lot of data, maybe 50 or 60% of the age range is from the age data is from 2.7, 2.5 to 3.8 billion ago, and in the calculation we usually assume that this area distribution of those data is normal distribution. So I think this pattern for the King map examples is reflected the distribution of this age range. So so time series pattern of King igneous geochem data for seems not accurately right according to our correct data if we just use the data downloaded from the Earthscan category. So because up to now we have only completed about 1/3 of those data. So next we will still check and apt the data, and we will still add some geochemical data published in Chinese, which is not included in the databases, and we'll still complete this. And after all this work, I think we will get a whole pattern of the data, and we still plan to update the periodic data after after completing Archean databases. So that's all. Thank you.
All right. So I guess we still have some time before Zhangzhu gets here. I don't know if there's things you want to discuss in the meanwhile. Yeah, so the quantization of data, they put everything with a very large age range, but then just round it to some middle number within that range. That's definitely a big thing in EarthChem data, both for this age and for younger. And yeah, as I think you noticed, what we did in Keller and Cheney was to just resample that with those large uncertainties, which usually the data is accurate within the uncertainty, but the uncertainty is just massive. So you don't get all the fine details of the pattern that you would if you had the real ages. So it's great to have the real ages, and I expect that will change things. But I think it will be important if you want to look at the pattern for the Archean to also include the younger rocks. So because a large part of in those Keller and Cheney trends, a large part of that, like it is what you're saying essentially. It's you have a lot of data that is older that has a Gaussian. You have data that's younger that has some other distribution, and you get essentially mixing between those. But those younger samples potentially still need to be included. Unless you also update the ages of all of there's going to be, I think in doing the Markov chain, in doing the plain Monte Carlo bootstrapping, I think it's going to be important to have the younger rocks too, because some of those will actually have possible ages in between. And but yeah, I think it's going to be really interesting to see what you can do when you have all the correct ages. The other thing, though, I think, I'm not sure if you know, the Keller and Cheney data is actually not just EarthChem. I'd say about half of the Archean data in there is not EarthChem data. It's from Kent Condy and Jean-Francois Moyen. So that data tends to have much better age constraints than the EarthChem data. So that, which also brings the numbers up a bit, but that may be worth considering as well. You may already have that Moyen and Condy data in your new data set as well, but if not, it would be good to get it in there.
Okay, I think you give. I think this data is included in your spreadsheet.
Yes. So if you were working from that, it should be in there. If you were but if you were working from direct downloads from EarthChem, it might not be in there.
Okay.
Yeah.
But after looking the original publication of those data, and I think a lot of age ranges right for those data, and we just correct them, and we want to know the accurate pattern or more precise pattern of this data.
Definitely.
Yes, I think we will still include more younger samples in our next work, because it spent a lot of time to check out publications. So we're still working with that. Yeah,
it's a huge amount of work.
Yes, maybe after work we will see a new, or maybe a new pattern of this data, I think, and we also can use this new data to solve other problems. Not, for example, the chemical composition of the Archean crust, or the evolution history of the continental crust. And yes, I think.
Sounds good.
Yeah.
I guess we can wait a few minutes and come back at 11:20, unless there are things people want to talk about.
Yeah, he's still in another meeting.
Yeah.
He's still in another meeting.
Sounds good.
Hello, Brehnin. I have a question
Sure.
for you. And during checking the original publication, up to now, we found that a few samples published in 2017 to 2020. So those these I think these published data are not completely into this database. So and just do we need to found this publication to include them in the databases?
It's a good question. I think it's always good to have more. I guess it depends how much data is in the new papers compared to the old papers. If the new papers are including more data per paper than the older ones because analyses have gotten faster or cheaper or something, then it might be good to include them. If not, if it's just another few years of papers, then yeah, it would still be great to include them. But it's just a balance of how much time you have and where to spend it, and that's
yes. We still have to search them and see how many publications and how much data in these publications. Yeah. Yeah. So
sure.
and yes. So and do you have any idea for this for this Archean Crust competition or using the Crust and data?
I mean, using the new data in particular, or just ideas about the composition of Archean crust in general?
Using the Crust data to estimate the composition of the Archean Crust.
So I think one worthwhile approach would be looking at essentially the differentiation as a function of silica for different age bins to see how as you go from whatever the relatively mafic mantle derived end member is for given time to relatively felsic rocks, how that influences basically how the differentiation changes over time. And you compare that from relatively modern back into the Archean, because the pattern does change a lot, and I think that matters a fair amount in trying to reconstruct from any given proxy what that actually means in terms of silica. I think that's one useful thing to do.
Yeah. I'll try it because I'm still using the data to plot the silicon time series pattern, and I think it did not change much according to our correct data. So, Professor Joe, do you have any question or problems to discuss?
No. First, I apologize for being late.
No.
And can I express or discuss with you so that we could move forward with next step?
Yeah. So I guess my first thought was, we've known for a while that those points where they have a whole ton all at one random number, usually something 50, are basically where they're just taking a category that they have extremely bad on the same category, so it has an old end member and a young end member, and you just give it a nominal age somewhere in the middle. And we've known for a while that those are very inaccurate because we didn't have the actual data. So it's great to see the actual ages for that. That's a lot of work. So that's nice to have that tracked down. And then as far as the pattern over time, I think it will be important to include basically the Proterozoic as well, to see whether you still do ultimately have a concave up or whatever, or not pattern. Whether you still seem to see cooling around the end of the Archean, because it's a time of unusually sparse data. It could actually be worth trying to find more data in that window. In fact, actually, I know Chris Spencer who is now at Queen's University in Canada, has a bunch of extra data from that time period, has been working on that time period, and is interested in doing work on the data he has compiled from that time period. There could be a potential collaboration there. But in any case, I think that that time period where there's just relatively little data from sort of 2.1 to 2.5 will be probably pretty important. And then seeing what happens after 2.0, because I think it's going to be high magnesium in the Archean. The pattern's probably going to change a little bit. It's certainly going to be lower by the time you get to 1.5 GA, 1 GA, probably even 2 GA. Maybe not by 2.4 GA though. So I think in order to look at the whole pattern on the scale of Earth evolution, I think it'll be important to either include just existing data sets of younger rocks, or try to repeat this same process also for younger parts of the data set.
I think that's also the future work to do, because in short, still trying to wrap up the Archean data. Actually, it takes a lot more work because the protozoic data set is about 3 to 5 times larger than the Archean ones. But I would like to, that's something that's on the way. Yes, surely we need to do it. But I have another question to consult with you. Is that when we get the igneous rock data, is it possible that we could contribute or collaborate with the, let's say, the sedimentary geochemistry and paleoenvironment? So whether we could contribute this data into those ones, so that we could also take advantage of the, let's say, the sedimentary geochemistry at the same time, at the same.
That's a good question.
Archean data that has not been published, but we could contribute to this too. So I don't know whether it's possible. If it is possible, how could we move forward?
I think probably yes. SGP is slowly working its way back in time. I think they're getting more Proterozoic data. They haven't focused yet on the Archean, but that's the direction things they're going older. So maybe eventually they will get there. It could be worth reaching out. So I don't know when next time I'm going to see Sperling is, but Eric Sperling is sort of the one in charge of all of that, and it could be worth talking to him about whether it's worth. Because I think it would be worth trying to link a igneous reanalysis with a sedimentary reanalysis, but I don't think they've focused on the Archean yet. But if we talk to them about that, maybe that would help push that along.
Because for the time, we move from Archean and graduate to Proterozoic. So in the end, we will both have Proterozoic and Archean.
Yes.
So this is not something
working opposite ways. It could work out.
Yeah, I don't expect this will be something that will occur very recently, but I think that in the, let's say, foreseeable future, I would like to see what's the mechanism that this igneous geochemistry data set could cooperate with that one. So
I think it would be worth talking to Sperling about that. I think that would be interesting.
Okay. I'll talk with you first, so that if you could make Eric at some point, and as we are committing more data, then I contact him and make some more, let's say, formal introduction to and move forward with the project. Yeah,
sounds good to me.
Okay, I think we have kept you pretty late. But before we end the meeting, but are there any other questions from other participants in our project?
It's cool to see the amount of person time put into this, because it's a lot of work.
Okay, could everybody open your video so that Brehnin could at least see who you are networking that have done such a tremendous amount of work to contribute to the database. Okay, please open your video just briefly so that before we end the meeting. Okay.
So you're the ones who've been compiling all the data.
Yeah. Okay.
Nice work.
Okay. I think that's so much about the meeting today. And yeah, have a good field trip
All
tomorrow.
right, thank you. Yeah, I'll get
Yeah.
back to packing.
Yeah.
Have a good one.
Yeah.
Goodbye.
Yeah. See you in a month or two. We could have another meeting once we
Sounds good.
reach the new phase of
Yeah,
data analysis. Okay. See you. Thanks, everybody. Bye-bye.